Okay, so for those of you guys that can't be in class, we're going to give this a shot today. What we are going to be talking about in this chapter is a pretty big word called stoichiometry. Okay, there it is, stoichiometry. The way I like to think about it is not that big giant word. I like thinking about it as recipes. Because I don't know about y'all, but I can tear up some food, and I would much rather talk about food than anything else. So, let's look at this. Recipes, okay? If I am making spaghetti, I need 1 jar of sauce. I need 12 ounces of skitty noodles. And then, just, because it's me, I need like a gallon of mozzarella cheese. But we'll make it simpler and we'll say half a cup of mozzarella cheese. That right there is a recipe. Okay, just a recipe. Very, very simple recipe. 1 jar of sauce plus 12 ounces of noodles plus half a cup of mozzarella cheese equals spaghetti. So another way to look at this, I stutter on a computer too, is saying 1 jar of sauce plus 12 ounces noodles plus, that's a plus, not an and. Hey, let's try this out. Plus 1/2 cup of cheese. And we can make this a chemical equation. Yields dinner. In fact, that yields 1 dinner. Okay, so there's my chemical equation. That's what stoichiometry is. I'm looking at recipes. So this all makes 1 dinner, but let's say it's not just you. It's you plus your cute green friend. So in order to fix your cute green friend dinner, you got to relook at the recipe. By the way, if you're eating a jar of spaghetti sauce by yourself, dude, really? Let's just go with it. So let's say it's you, your friend, and you need to think about your recipe. So now instead of 1 jar of sauce, I got to think about this. What do I need to make not 1, but 2 dinners? Well, that's easy enough. I need 2 jars of sauce. I need 24 ounces of noodles. And I need 1 cup of my cheese. I've doubled everything. That's stoichiometry. Easy. Think about it in terms of vehicles. We're going to make this really, really overly simplified. What if I tell you that 1 body plus 4 tires plus 2 axles makes a car? Clearly, that's not simple, okay? You start thinking about things like, well, all right, what if I had 12 tires? How many cars could I make? And you guys are already thinking about this right now, and you're thinking that's easy. If you had 12 tires, you could make 3 cars. That's stoichiometry. What if I had 4 bodies, which sounds really disturbing, 8 tires, and 16 axles? How many cars could I make? Again, you're looking through your ingredients and you're saying, well, that's easy. You could make 2 cars because I only have enough tires for 2 cars. That's stoichiometry. So as we go through this unit, you're going to see a lot of this repetition of recipes, except instead of these recipes, we're going to be looking at chemical recipes. So today's lesson starts with the most basic. Then we'll expand upon it in the next lesson. We'll start with a simple chemical reaction. We'll do nitrogen plus hydrogen produces ammonia. Number 1 thing you have to know about stoichiometry, you must balance the equation. If the equation is not balanced, it doesn't work. Think about it in terms of the stuff we were just talking about. Okay, if I just said a body, a tire, an axle, that doesn't make a car. If I said a sauce, 1 noodle, and a piece of cheese, that's the saddest plate of spaghetti I've ever had. So we have to have our quantities right in order for any of this to work. So let's balance that equation we just had. I'm going to put it back on here. N2, because it's diatomic, plus H2 yields NH3. So I go through and I balance my equation, 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens, there I go. So the first thing we're going to learn how to do is a mole-to-mole conversion. Mole to mole. The coefficients that are in front of your compounds or your elements are moles. In this reaction, I'm taking 1 mole of nitrogen plus 3 moles of hydrogen to make 2 moles of ammonia. So the simple question is, I could ask you, what if I had 2 moles of nitrogen? How much could I make? What if I had 6 moles of hydrogen? Those are easy, you can do them in your head. But what if I said to you, you have 4.3 moles of nitrogen, how much ammonia could you make? This one might be a little bit harder. You might have to think about it a little bit more. Better yet, what if I said you had 4.3 moles of nitrogen, how much hydrogen would you need to go along with it? Okay, and how much hydrogen would need to react with it? These problems are called mole-mole problems because if you look at them, you're going from moles of this to moles of that, and that should have been written over there. So let's look at one of these. We'll go back to the same equation we had. N2 plus 3H2 yields NH3. 2NH3. If I gave you 4.3 moles of nitrogen, and I wanted to find out how many moles of ammonia I could make. To do a mole-mole conversion, you know what's coming. You are going to draw a cross. Hooray! You are going to do exactly what we've done this entire time. 4.3 moles of nitrogen. Down here on the bottom, moles of nitrogen. And you'll notice when you're doing these things that having the element actually named in here will make your life much, much simpler. So now we're going to add the top unit. We want moles of N3. So now we have to figure out what's going to go in these two places. Numbers are going to fit in for moles over moles. And we're going to use what's called the mole ratio. The mole ratio is very simply the coefficients from the balanced equation. That's the mole ratio. So if I look at NH3, there is a 2 in the balanced equation in front of NH3. That 2 is going to go right there. In front of N2, I have a 1. So that 1 that's in front of NH2 comes down here, right there. And that's it. Then I solve it. 4.3 times 2 divided by 1 is going to give me 8.6 moles of NH3. This right here is called a mole ratio. Let's try another one. This time I'm going to give you a different equation. We'll do hydrogen plus oxygen makes water. I'm trying to give you some simple equations. So again, first thing you always have to do, balance your equation. So as I balance this equation, it's a pretty easy one. It's done. And now your question says you have 1.3 moles of hydrogen. How many moles of oxygen will I need for this reaction to occur? It's like saying, if we go back to our car or our spaghetti, what if I only have 6 ounces of noodles? What if I only have 3/4 a cup of cheese? What if I'm adjusting one ingredient? How do I adjust the rest? So again, the way you solve this is you draw a cross. You put in your given, 1.3 moles of hydrogen. Then, unit of my given down here, unit I'm looking for up top. All of that's the same. Now I need the mole ratio, which is going to be the coefficients from my balanced equation. So I look in front of O2, and there's a 1. I look in front of H2, there's a 2. So to find my answer, it's 1.3 times 1 divided by 2. And my answer ends up being, I'm going to come down here on the bottom where I have some room, 0.65. And that's moles of oxygen. Those are called mole-mole conversions, and we'll add more to it next time.